So hi everyone. So in the continue of the part 1, I explained the basic about the module. Okay. So in this part, if you write the Verilog code of any digital block, so what should be your procedure? Okay. So just right now I'm writing the syntax. Okay. Just try to understand. If you have any doubt, you can ask me. Okay. I explained already the every Verilog code will start from the module keyword. Okay, then you need to write the module name. So module name, it is the variable and it is the name of object that digital block you are going to design, so it should be meaningful. Module name. And then inside of this a small parenthesis, you need to write the list of port. What are the meaning? I will explain, don't worry. List of port. Okay. Then here you need to define the port declarations. Yeah, port definition you can say. Port definition means, I will explain, don't worry. Port definition. This is the general syntax of the every Verilog port. Port definition. Port definition means it can be input, it can be output. Port definition means it can be input port, output port, yeah, in output means it behaves input as well as the output. Then you need to define in out. Okay, I hope you understand. So firstly, module name and list of port inside the small parenthesis. This is the semicolon. And one thing you should remember, in the Verilog, just the syntax is based on the C language. So every statement in the, yeah, finish with the semicolon. Okay, you should remember this thing. So this is the port definition. Okay. After that, you need to write here the parameter. Meaning of what are the meaning of the parameter? Don't worry, we'll know in very details. Parameter and the data type. Data type. Then here inside them we'll write the Verilog code. So what procedure and what the level we will follow? We have a four level of abstraction. This is called the level of abstraction. Level of abstraction. Okay, and I already explained every module finish with the keyword in module. I hope you know. I hope you understood this thing. Okay. Okay. So this is the basic and so this is the basic and common module syntax for every Verilog code. Every Verilog code. Okay, I'm explaining again. Every Verilog code will start from the module keyword. Then you should write the module name. Module name, it should be meaningful. What are the meaning of meaningful? Just wait. Just wait 2 minutes. MEA, and Gemini full. Okay, this is the name of the object. This should be a meaningful. Okay. Then you need to write the list of port. What are the meaning? Okay, I'm explaining list of port. So list of port you need to define here. List of port means how many input and output you are going to design in your the digital block. Okay, so port define you need to do here. Port definition. Then the parameter and the data type. Parameter means if you define the parameter anything like like you are giving as parameter uh, real esme 2.4. Okay, so overall the simulation throughout the simulation s is fixed to the 2.4. Okay, that are the meaning. And you should define here the data type if required. Here data type means there are the only two data type is there in the Verilog: net data type and the range data type. Okay, after that you need to write the level of abstraction. Level of abstraction, Verilog provide the four level of abstraction means while writing the code: get level modeling, data flow modeling, behavioral level modeling, and switch level modeling. If you want to write, you can write, otherwise later I will explain. Level of abstraction, get level modeling. If you ask me to write, so you can write the get level modeling. Okay, then the behavioral modeling. and then the data flow modeling. So this is the way to write the Verilog code. In every syntax, meaning is in every code, meaning is same, but syntax will differ something. Okay, and the switch level modeling. Mostly this thing we don't use. SW switch C. And in this part, I will explain one thing also. See, so I mean, suppose you are going to design the half header. Okay, half header. So how can we think the list of port? Yeah, anything. So for this, okay, I forgot this to write. Switch level modeling. So this is the fourth level of abstraction. Okay. So this is the common syntax for every Verilog code. If you want to write the Verilog code of the digital block. Okay, I am explaining here. Sorry. Just I give one example and you will understand this thing. This is the oldest part. Just I am deleting. Okay. See. So suppose you are going to design a half header. Half header. So you know the functionality and the behavior of half header already. In that the two input is there. One is I am writing A and B. So there is the two input is there and two output is there. One is the sum and one is the for carry. Okay na? So this is for carry and this is for sum. Okay. So right now you are going to design, yeah, you are going to implement the half header and how can we write the Verilog code? Okay, just syntax. Try to understand this thing. Firstly, first of all, you should think how many input and output port is there. How many input and output port is there? Means list of port means IO port. If you ask me for to explain later in the ask me to explain in very details, then list of port means IO port. How many IO port is there? See here, how many port is there? Two is the input port, two input, and output is two port. Sorry, output is the I think sum and carry. They are the two output is there. Okay. So first of all, you should write module keyword. Then I told the module name should be meaningful. Module name should be meaningful. It is the name of the variable. So there is some rule while writing the name of variable. I will explain the in later video, in upcoming video. Okay. So module and then we should write the module name. But module name should be meaningful. Module name should be meaningful. Meaningful means suppose you are going to design the half header. So you can write here the half, but space are not allowed. Space are not allowed while writing the variable in the Verilog. So there is a some rule. So but the underscore you can use. So half header underscore you can use half header. So this should be a meaningful. Suppose you wrote this code already, and some your friend is coming and asking like that. Right now you wrote the Verilog code. So I mean, what are the meaning of that, and what the digital block you implemented here? So your friend, if see the name, this is the half header, so he will understand automatically. Okay, so right now you are designing the half header. So the module name should be meaningful. I am going to design half header, so you should write half header. And inside of them, you need to define the port of list. Port of list means how many IO pin is there. IO pin A and B, that is the input port A and B, and output is for S is sum and C is carry. And every statement finished with the semicolon, just like a C language. Okay. Right now, I told, I explained here. So you need to define the port definition. Port definition means which one is the input port and which one is the output port. Okay, sorry. Okay, so which one is the input port and output port? So input port is A and B. So A comma B is the input port, and what are the output port? Output port is sum and carry. So in this complete module, I am not going to design any variable that value should be constant always. If I define if I define like the parameter, suppose if you define here the parameter and real, just I am writing s the 2.4. So I mean the throughout the simulation, the value of the parameter, the value of the variable s 2.4 is fixed. So if any kind of right now I'm designing the a small digital block like a half order, but in the big design so many variable is there, so that time it is a useful technique. Okay, but right now no meaning I'm designing the small block, so sometimes it is useful, sometimes not. So that's why I explain the general syntax here. Okay, and here also you need to define the data type. What the data type you are going to so what the data type means, what kind of the data type you are using in your in the designing. Okay, so we'll explain later. There are the two data type. One is the net type and the one is the range type. Net, that is the automatically the name is wire. So we'll explain later. But in this lecture, I want to explain what are the meaning of the list of port. So list of port you should write here whatever the input IOPin is there. Just you should define in the curly sorry a small parenthesis. Then port definition, parameter and the data type. Then this is the level of abstraction. After that you should come the level of abstraction. What are the meaning of the level of abstraction? Level of abstraction means Verilog offer four level of abstraction. While writing the Verilog, how can you map the functionality of the half header? Actually, you know already the sum expression is XOR gate, and you already know no? So this is the sum expression, and the carry is A and B and gate. You know already this thing. So how can you map this functionality in the Verilog language? So for that there is a four level of abstraction is there: data flow modeling, I mean behavioral modeling, gate level modeling, and the switch level modeling. So in this part, actually these four modeling, these three module modeling, switch level modeling basically we use in the analog circuit. Yeah, separately we have a language Verilog A. So we in the last I will explain something about the switch level modeling. This is not much important, but the gate level modeling, data flow modeling, behavior level, this is most important thing. You need to write everything. I mean, sorry, you need to write the Verilog code by the help of this level of model. Okay. So in this lecture, here I am writing the Verilog code with the help of the data flow modeling. Data flow modeling. Okay. See, so the identification of the data flow modeling. How can you identify? So this is the data flow modeling. Actually, later mostly the data flow modeling and behavioral modeling be combined to each other. No issue. You can combine. Yeah, if you not combine, then also no issue. Okay. So the identification of the data flow modeling is assign keyword. ASSIGN, assign keyword. Okay, just you should write here the functionality assign, and what are the functionality for sum assign some functionality, that is the XOR gate. So in the Verilog we'll know in the upcoming video the operator. What are the operator in the Verilog? So right now I am using for XOR operation. There is a there is a functionality. There is a XOR B. So this is the meaning of the XOR gate. XOR functionality. If you do synthesis, then the tools will generate the XOR gate. This is the functionality of the XOR gate. Okay. Then assign carry for AND gate. What are the functionality for AND gate? This is the AND gate functionality. So if you AND, finish with the IN body. Okay, I'm explaining about actually assign statement, something you should remember also. Okay, so right now, actually I wrote here the Verilog code for half header. This is very easy. I explain step by step. You should write this way and the port of declaration. Then the Verilog have a four level of abstraction, basically three level of abstraction. So here I explain how can you write the Verilog code using the data flow modeling. In next part I will explain the behavioral modeling. We'll explain in very deep. We'll explain this complete modeling in the very details also. Okay. So this is the data flow modeling syntax. How can we identify the assign keyword? So assign sum A XOR B. What are the functionality for XOR gate? Just I am writing the comment. For XOR gate, the functionality is this one, this symbol. Okay. If you go on the keyword, then so this symbol is there. Okay. And for AND gate, so what are the functionality is there? This is the symbol percentage. ampersand. Okay, so this is the two symbol is there. So right now I explain how can we write the Verilog code using the data flow modeling. Just I am explaining in the short. Okay. So there is just something about the assign keyword also. Okay. One thing I am telling, and also you should remember always also. If you define the list of port and you are not the declaring which one is the data type, wide data type, yeah, rich data type. By default, this data type is the wide. This is the most important thing here I told. Okay. If you write the list of port ABC and if you ask me, sir, so what are the data type is there for this variable? By default, there is a wide. Okay. A and B also wide and S and C is also wide. But if I define here, suppose if someone come and here wrote the S and C, range S and C, then sum and carry will be the range type. Otherwise, if we don't define any variable as a range type, by default it is a while. By default it is a while. Okay. By default it is a while. I hope you understand. This is the very important point I explained. So while defining the port A, B, C, S, these all are the wire data type. Okay, until and unless when we define the range data type. And one thing is there about the assign statement, the left hand side variable, this variable, and this variable. Later I will also explain. No worry. This and this variable should always should be the wire data type. Always. This is the true. Actually, I am writing syntax also. Assign and so this is the left hand variable. Just I am writing here the sum. Just I am giving example. Here I am giving example. And suppose any functionality is there, any I mean any functionality is there. Suppose for example, here sum is the XOR gate. Okay, any functionality is there. So don't confuse with them. Any functionality and B. Okay. So this is the left hand variable. Left hand variable and these all are this four is this A and B is the right hand variable. Okay, right hand variable. So this variable S must be in the while tab, must be in the while tab, always while tab. Where this is the data type, we'll explain later, don't worry. So this variable should always while tab, and this is these two A and B. It can be wire, it can be wire, it can be wire, Yeah, raise. Don't no issue. So A and B can be where can be raised, but the assigned keyword, the left hand side variable must be a while type. You should remember that thing. This is the most important thing. Must be a while type left hand side variable. So this way here I explain. That's why I explain every port until and unless if you are not defining the raise type by default is a while. So I can use here S and C. Okay, but if you have a confusion in the earlier stage, right now you are a beginner, so no issue. Here you can also write while s comma c. This is the statement you can also write. If you write, it is okay. If you don't write, it is also okay. The Verilog compiler will understand automatically. Verilog compiler will understand automatically. Okay, I hope you understand this thing. Okay, so in the next part I will explain how can we write the half header using the behavioral modeling. Don't worry, I will explain data flow modeling, behavioral modeling, get level modeling in very details. Just I am connecting in the starting and I am giving the confidence to you. This is the easy. You can write the Verilog code of the any the digital block. Okay, so thank you. This video is all about that. In the later video we'll meet. Okay, thank you.